Hello everyone, this is Amit. I welcome you all in the video lecture series of the subject Operation Research. This is our third lecture related to the chapter Assignment Problem. In this particular lecture we will see some special variations in assignment problem. There are some special cases in assignment problem that we will see in this particular lecture. So moving forward to our first slide of discussion. Maximization case in assignment problem. Till our second lecture we had seen minimization case, and that was solved using Hungarian method. So now there is some special cases in assignment problem, and in that the first one is maximization case. So let us begin with one example. There are 4 salesmen are to be assigned. There are total 4 salesmen are to be assigned to 4 districts. Estimates of sales revenue in 100 of rupees for each cell are as under. There are 4 districts and there are 4 salesmen. So give the assignment pattern that minimize the sales revenue. Revenue means collection of money. So it is but obvious that revenue should be always maximized. It should not be minimized. So this is a case of, if the word revenue comes, then you must have an idea that it should be always maximized. So there are 4 salesmen and there are 4 districts. Now you need to identify the assignment pattern in such a way that it maximizes the sales revenue. So this is a table that is given to you. There are 4 salesmen, 1, 2, 3, 4, and there are 4 districts A, B, C and D. Sales revenue in 100 of rupees. Hundreds of rupees is given in the table for each cell that is as under. So this table is given to you for the reference. Now we will start solving the example. What are the steps one needs to take to solve such examples? So once you have identified that this is a maximization problem, so what is the first step? Your first step should be to convert the problem into minimization problem, because Hungarian method is only applied to minimization case. So your first task will be to convert the problem into minimization case by subtracting from the highest element from this table, given table. You need to identify the highest element or the largest value. So you can see from the table the largest value that is available with you, that is 420. Among all the values in the table, the largest element is 420. So subtracting all the elements of table 1 from this highest element, that is 420, and then after you will be able to convert this problem into minimization case. So moving to our next slide. This is the second step. After subtracting this table 1, after subtracting all the elements from the largest element, you will get this table. Now this problem is converted. After the conversion, this table 1 will give you the problem that is converted into minimization case. Now step 2, develop opportunity cost table that is shown in table 2. So what is the procedure to develop the opportunity cost table? First step is row reduction. So from this reference table 1, we have taken table 1 as a reference and we have done the row reduction. So in the first row, the smallest element is 20. So subtract it from all the other elements in that first row and subtract it from itself also. So subtracting 20 from 100 will give you 80. From 70 it will give you 50. From itself it will give you 0, and from 140 it will give you 120. Similarly, for the second row, the smallest element is again 20. Subtracting from itself it will give you 0. From 150 you will subtract it. From 170 you will subtract it, then it will give you 150. From 120 it will give you 100, and from 200 if you subtract 20, then it will be 180. For the third row, as there is 0 already present, so subtracting 0 from all the other elements will remain as it is, so that row values will not change, it will remain as it is. Similarly, for the fourth row, the smallest element is 10. Subtracting it from all the other elements will give you 160, 20, 0 and 60. So this is the row reduction. Moving forward to the second sub point, that is column reduction. So now in column reduction we will take this table 2 as a reference and we will do the column reduction. So for column A, there is already 0 present in the first column, so there is no change in that column because subtracting 0 from all the other elements will remain as it is. The change that will take place, that is in B column. The smallest element is 20, so subtracting 20 from 50 will give you 30. Subtracting 20 from 150 will give you 130. Subtracting 20 from 150 will give you 130, and from itself it is 0. This C column again contains 0, so this column will remain as it is. Similarly, for D column, the smallest element is 60. Subtracting it from all the other elements will give you 60, 120, 60 and 0. So this is the table 3, that is of column reduction. So that table we will use as a reference to do the assignment. That is our third step. So moving towards our next slide, that is third step, make an assignment shown in the table 4. So third table that we had obtained during the column reduction, that is again rewritten, and now we will do the assignment as per the rules that we had already seen in our previous lectures. So starting with the first row, if you see a single 0, then make an assignment. So you can see the first row is having a single 0, so I have done the assignment and crossing out all the other zeros that belongs to that column or that row. So already I have crossed this 0. Then coming to the second row, there is also a single 0, so we had done an assignment and crossing all the zeros that are in that row or in that column. So that 0 is also crossed out. Similarly, there was only one 0 in third row, that was already crossed out, so there is no chance to do the assignment. Moving to the fourth row, there are 3 zeros, so as per the rules we will neglect it, we will leave it is as it is. Then starting with column examination, first column is already assigned. Coming to the second column, there is single 0, so we have done the assignment over here and all the other zeros belonging to that has been crossed out. So now you can see there is no chance to do any assignment in any zeros, or any cross outs can be done. There cannot be any cross outs to be done now. So now you can see there is third row which remains unassigned. So as per the rules, we must have each row and each column must have an assignment to obtain the optimal solution. But here this third row is having no assignment, as well as fourth column is also having no assignment, so we have not reached the optimal solution. So moving towards the fourth step, draw minimum number of horizontal and vertical lines such that it covers the 0 ones. So this table 5, we have drawn the number of horizontal and vertical lines. So tick marking the row that is unassigned, so that was the third row. Now checking that ticked rows cross 0 belongs to which column. So it was this A column, so we have ticked A column. Now that ticked column, you need to check for the ticked column assigned 0 belongs to which row. So you can see it belongs to second row, so that's why this has been ticked. Now there is no possibility of more tick marks because all the zeros has been considered. Now for drawing the horizontal line and vertical line is always drawn from the ticked column, that is this, drawn from A, and horizontal line is drawn from this unticked rows now. So you can see row 4 and row 1 is unticked, so drawing the horizontal line from 1 and 4 and vertical line from ticked column. Now you can see all the 0 elements are covered by this horizontal and vertical line. So now among these uncovered elements, identify the smallest element. So you can see this 60 is the smallest element that you need to subtract from all these uncovered elements, and you need to add where these two lines intersect, but the lines which passes over the element, that value will remain as it is. So that is shown in our next slide, table number 6. So here the line was intersecting and it was 80, so 80 plus 60 will give you 140. Rest of the values will remain as it is. This 0 was as it is. Here it was uncovered, so 130 minus 60 will give you 70, 40, 60, 0, 70, 20, 0. Here again it was an intersection, so 160 plus 60 will give you 220, 0, 0. So now you have seen that these are the values that has been obtained by subtracting the uncovered elements. So this is the table 6. Now again, following the same procedure to obtain the assignment. So we had followed the same procedure of doing the assignment, and now you can see that all the rows and all the columns are having an assignment. So as per the rules, you can say that an optimal solution is achieved or reached. So now to maximize the sales revenue, the assignment pattern is shown below. How the salesman is assigned to a district in such a way that sales revenue is maximized. So for the first salesman it is district C, for the second salesman it is district A, for the third salesman it is district D, and for the fourth salesman it is district B. So in this way, or in this pattern, if you assign the salesman to the districts such that it will maximize the sales revenue, and this all the values are obtained from the main table that was given you in the data. So according to the data that has been put from the given table, you can say that it gives you 1490. So this is how it will maximize the sales revenue, and in this way if you are assigning the salesman, it will give you 1490. Moving to the next slide. This is a special case of an assignment problem. First we had seen the case of maximization. Now moving towards the second special case, that is unbalanced assignment problem. So for that also we have taken one example for your understanding. Unbalanced assignment problem is nothing but there are not equal number of rows and equal number of columns, means it is a non-square matrix. Assignment problem is always solved for square matrix. So for the given data, let us see what happens. Solve the adjoining assignment problem of minimizing the total time for doing all the jobs. So for when it comes a case of jobs, machining a jobs, your main objective should be always to minimize the total time taken for doing the jobs. So as it is in minimizing the total time for doing all the jobs, so it's a minimization case. And there are 6 operators and there are 5 jobs. This is the time taken that is given in hours in the table. So you can see there are 6 rows and there are 5 columns. So this is an unbalanced problem. So for that, to make an balanced problem, we will have to add a dummy column, dummy job, that is 6, which will have all the elements of 0, which will have the value of 0, because that ultimately does not affect our final solution. So we have done by adding the dummy column job 6 to make it as a balanced problem, and now we will apply the Hungarian method. So moving towards the next slide. Develop an opportunity cost table. So the first step is row reduction. So you can say each row is having 1 0, so all the row values will remain as it is, that is shown, that I have not written. So now coming to the column reduction. So taking this main table as a table 1 as a reference, column reduction, smallest value in the column 1 is 2, so subtracting 8 from all the other values, so it will become 4 0 5 4 7 and 2. 4 0 5 4 7 and 2. Similarly, this column values will also change because the smallest element we need to identify. So this is the table 3 that is obtained after the column reduction. So now for doing the assignment, we will follow the same procedure I have already done in this table only. I have not drawn separate table for it. So as per the rules of doing the assignment, we have done the assignment by examining each row and each column individually, and we had found out that there are 2 rows which remains unassigned. So to obtain the optimal solution, we must have each row and each column with 1 assignment. So this is not the case, and we have not reached the optimal solution. So for that, to solve that problem, draw minimum number of horizontal and vertical lines. So we have 5th and 6th row with 0 assignments. So we have ticked this 5th and 6th row. Now for that, the ticked row, what we need to check, that cross 0 belongs to which column. So for 5th row and for 6th row, cross 0 belongs to 6th column. So we have ticked this column 6. Now that ticked column, assign 0 belongs to which row? So you can see for the ticked column, assign 0 belongs to 3rd row. So this 3rd row is assigned. Now for that, drawing number of minimum horizontal lines, for that, now horizontal lines will be drawn from unticked rows. So 3rd row, 5th and 6th row are already ticked. Unticked rows are 1, 2 and 4. So drawing horizontal lines from 1, 2 and 4, and vertical line will be drawn from the ticked columns. So this is how the horizontal and vertical lines are drawn. Now you can see that all the 0 elements are already covered by this line. Now among the uncovered element, the smallest element is 1, so subtract it from all those uncovered elements, add wherever the lines are intersecting, and those values over which the line passes, that values will remain as it is. So that is shown in our next slide. So as per that, these are the values that we have obtained after subtracting and adding wherever the lines. So now assignment is done as per the rules. Now you can see 1st row is having an assignment, 2nd row is having an assignment, 3rd row is having an assignment, 4th row is having an assignment, 5th row is having an assignment, 6th row is having an assignment, and each column is also having an assignment. So we have reached the optimal solution. So in which way the operator should take a job such that it will minimize the total time taken. So operator 1, job 4 should be assigned. For operator 2, job 1. For operator 3, job 6. For operator 4, job 5. For operator 5, job 2. And for operator 6, job 3. Now putting those time that was available in the main table, for doing the first, for operator 1, job 4, it takes 3 hours, and if you make a total of all those time taken, it takes 17 hours. So this is how the pattern of assignment is done, such that will minimize the total time to do the jobs by the operator. So that is 17 hours. So this is all about unbalanced assignment problem. Moving to another special case, multiple optimal solution problem. So this is a special case of an assignment problem. This is the data that is given to you, and in this particular problem you will have multiple solutions for the given problem that we will see in the coming slides. So an automobile workshop wishes to put 4 mechanics to 4 different jobs. The mechanics have somewhat different kinds of skills, and they exhibit different levels of efficiency from one job to another. The manager of the workshop has estimated the number of man hours that would be required for each job man combination, and this is given in the matrix table below. So there are 4 mechanics and there are 4 jobs A, B, C, D. The estimated time for job and manpower is also given in the table. So for mechanic 1, it takes 5 hours. For job A, it takes 3 hours. For job B, it takes 2 hours. For job C, and it takes 8 hours for job D. Find the similarly all other values are given for each mechanic. Find the optimum assignment that will result in minimum man hours needed. So how should assignment be done such that it will minimize the manpower hours, to minimize the manpower needed to complete the job? So the first step to the solution is develop an opportunity cost table. So in that, first sub step is row reduction, that is shown in our next slide. So you can see in this first row the smallest element is 2, in second row also it is 2, in third row it is 4, in fourth row it is 5. So after row reduction, what is the new table, that is shown in our next slide. So after subtraction, you find that the new values are 3, 1, 0, 6. For second row it is 5, 1, 0, 4. For third row it is 2, 0, 1, 3. For fourth row it is 0, 2, 2, 3. Now this table 1 is used as a reference for obtaining the column reduction. So for the first column, the smallest element is 0, so that column will remain as it is. For the B column, there is also 0 value, so that column will remain as it is. For column 3 also it will remain as it is, because 0 is the smallest element. For column 4, the smallest element is 3, subtracting it, so it will become 3, 1, 0, 0. So this is the column reduction table. Now moving to the second step, make an assignment. So this table 2 is again rewritten, and as per the rules we will make an assignment. So starting with the first row, if you find single 0 in that row, then make an assignment. So yes, there is single 0 and I have made an assignment to that row. Now crossing out all other zeros that belongs to that column or that row. So this column, there was 1 0 that was crossed out, there are no other zeros. So coming to the second row, there are no zeros that is remaining, so we will leave as it is. Third row, there are 2 zeros, so we will leave as it is. Fourth row, there are 2 zeros, so we will leave as it is. So coming now to the column examination, for this first column there is single 0, so I have done the assignment to that column and I have crossed other zeros. Then coming to the column 2, there is also a single 0, so we have done an assignment and crossed the other zeros. So moving to the next slide, now you can see row 2 is remain unassigned, so we have not reached the optimal solution yet. So next step should be to draw the minimum number of horizontal and vertical lines. So you can see now this second row has no assignment, so we have ticked this row. Now for the ticked row, cross 0 belongs to which column? So it belongs to C column, so this C column is ticked. Now that ticked column assigned 0 belongs to which row? So you can see it belongs to first row, so this is ticked. Now draw the minimum number of horizontal and vertical lines in such a way that it should cover all the zeros. So now draw the horizontal line from the rows that is unticked. So row 3 and row 4 are unticked, so we will draw the horizontal lines from that rows, and vertical line is drawn always from the ticked column. So this is how the ticked column vertical line is drawn. Now you can see all the 0 elements are covered. Now among the uncovered element, the smallest element is 1. So subtract it from all the other elements and other values from where the line just passes, that values will remain as it is, and add that value where the two lines are intersecting. So subtracting 1 from 3 will give you 2, from itself it will give you 0. The line is just passing from this element, so that 0 will remain as it is. Subtracting 1 from 3 will give you 2. From 5 subtracting it, so it will give you 4. From 7 subtracting it, it will give you 6. 0 will remain as it is, here it will become 0. This element will remain as it is because the line is just passing over it, so 2 remains as it is, 0 remains as it is, and here the two lines are intersecting, so 1 plus 1 will become 2. Here 0 will remain as it is, here 0 will remain as it is, 2, 3 and 0. So this is how the new table is obtained. And now as per the rules of assignment, we have done the assignment. So you can see each row and each column is having one assignment, so we have reached the optimal solution. That is our next step. As shown in table 5, you can see assignment is already obtained in each row and each column. So now you can see there are multiple solutions that can be available for the same problem. Using fifth table, we are showing you the assignment pattern. For first mechanic it is job B, for second mechanic it is job C, for third mechanic it is job D, and for mechanic 4 it is job A. So adding those man hours that is available from the main table, you can see now it is 17 hours. Similarly, you can do assignment randomly also when this type of situation arises. If you have done the assignment in this C job for mechanic A, that is shown in table 6, So this is also a solution that can be available in this. Mechanic 1 will take job C, second mechanic will take job D, third mechanic will take job B, and fourth mechanic will take job A. And when you do the addition of the time that was given to you, it is again 17. So answer will remain same, but the pattern of assignment will change. Answer remains same. So this type of problems is called multiple optimal solution problems, in which you can have more than one type of solution, in which assignment patterns will change but the original answer or the main answer will remain same. So I hope this would have helped you to understand about different variations or special cases in assignment problem. Thank you.